This lesson will demonstrate how to solve quadratic equations by completing the square. Completing the square is a process of finding the constant term that makes a binomial of the form x squared plus bx a perfect square trinomial. A perfect square trinomial is a trinomial that results from squaring a binomial. For instance, x plus 3 quantity squared is equivalent to x plus 3 times x plus 3. When we multiply this out, we get x squared plus 3x plus 3x plus 3 times 3 or 9. And that is x squared plus 6x plus 9. So x squared plus 6x plus 9 is considered to be a perfect square trinomial because it comes from the quantity x plus 3 squared. Looking at one more illustration, x minus 4 quantity squared is x minus 4 times x minus 4. Multiplying this out, x times x is x squared. X times negative 4 is negative 4x. Minus 4x, and negative 4 times negative 4 is plus 16. Simplifying, we get x squared minus 8x plus 16. Again, another example of a perfect square trinomial. So the question is, how does this constant in the perfect square trinomial relate to the other terms? So if we look at x squared plus 6x plus 9, note that 9 is 3 squared, and 3 is half of 6. And x squared minus 8x plus 16, 16 is 4 squared, and 4 is half of 8. So when we say that we are completing the square, we have to find half of the coefficient of x and square it. Let's look to see how this applies to solving quadratic equations. In example 1, I want to solve x squared minus 18x plus 5 equals 0. This is an example of an equation that does not factor. There are no factors of 5 whose sum is negative 18. Also, the square root property can't apply because we don't have just a quantity squared equals a number. But what we can do is get this equation in the form that we do have some perfect square on the left side. And so what we want to do is first remove this 5 from the left side, and we can remove it by subtracting 5 from each side to get x squared minus 18x equals negative 5. Now we want to complete the square. To make x squared minus 18x a perfect square trinomial, we have to use that relationship that the constant term is half the coefficient of x squared. So half of negative 18 squared is negative 9 squared, or 81. We add 81 to each side of the equation. We can do this by the addition property of equality. What we do to one side, we can do to the other. Now, x squared minus 18x plus 81 is a perfect square, and it factors, if you need to write this out, as x minus 9 times x minus 9. Negative 5 plus 81 is 76. The equation then is x minus 9 squared equals 76. At this point, we apply the square root property to get that x minus 9 equals plus or minus the square root of 76. To solve for x, we add 9 to each side to get 9 plus or minus the square root of 76. So it's really cool that we were able to have an equation that didn't look like it was solvable, but we applied this process of completing the square to be able to apply the square root property. So the solution set is 9 plus or minus square root of 76. So to solve a quadratic equation by completing the square, we will follow these steps. We first have to divide each side by a to make the leading coefficient 1. Completing the square only works when we have a coefficient of 1 on the squared term. Then we isolate the variable terms on one side of the equation. Complete the square, which is we add the square of 1/2 the linear term to both sides, and then we factor. And finally, we can apply the square root property and solve for the variable. Here's another example. We want to solve 2x squared minus 4x minus 3 equals 0 by completing the square. In this problem, we have a leading coefficient other than 1. Before we can start the process of completing the square, we divide each side by that coefficient, which is 2. This equates to dividing each term by 2. 2x squared divided by 2 is x squared. Minus 4x divided by 2 is minus 2x. Minus 3 divided by 2 is minus 3/2 equals 0 divided by 2 is 0. Now we want to get the variable terms on one side and the constant on the other. We do this by adding 3/2 to each side to get x squared minus 2x equals 3/2. Now we need to complete the square on the left. We take half of negative 2, square it, which is negative 1 squared, or 1. Then we add this number to each side. X squared minus 2x plus 1 factors as x minus 1 times x minus 1, or x minus 1 squared. 3/2 plus 1 is the same as 3/2 plus 2/2, or 5/2. Applying the square root property, we get x minus 1 equals plus or minus the square root of 5/2. Now we add 1 to each side to get 1 plus or minus the square root of 5/2. For the purposes of this course, we can leave it in that form to get 1 plus or minus the square root of 5/2.